So I have this lab for you, and I kind of want you guys to do it. But before I have you guys go into it, I want to just kind of set you guys up for the pieces of it. The first piece is going to be moving the ball. The second piece is going to be collision detection. As you guys saw, like last week in lab, really a ball that moves in a game is really just you repositioning the ball every frame. So how you reposition the ball every frame is right now kind of up in the air, like how you guys want to do it. SFML does give you some facilities to move the ball, move objects. So you can move something just by calling, literally you can take this shape here, and you can say every frame, I can just say shape.move. I can say like move at 0.1. And this right here says move at 0.1 pixels every time I go through the loop, right? This ball has some velocity to it. Can anyone tell me how many pixels per second that thing is moving? Anyone have any idea? It's hard to tell. 1 pixel per second? That's not true. It's actually like really hard to tell because it slows down if I have something else on the screen. So watch, I can slow this ball down just by moving the window. Because that ball is not moving relative to, see how I can slow it down by dragging the window? So this kind of movement here, it works, but you guys can see why that's a problem, right? You don't want to be all tabbed and then all of a sudden have your thing be moving faster or slower. But this works. The problem here is that you don't have any control over how long it takes for that ball to move across the screen. A lot of times in games, especially with regards to like games that have projectiles or games that have characters, you want to explicitly say, I want a projectile to move 100 meters per second, which is really fast. Or I want this character to move 5 meters per second. That is every second I want to move. How do I represent that here in this shape? Well, the right way you do that is you incorporate time into your movement. So you need to compensate for how much time has passed. This also goes back, and this is in a lab. I wrote this in lab for you. So you have a clock you set up. You have, again, the concept of time. And now that I have delta time here, I can move this thing however many pixels per second I want. I can move this thing 100 pixels per second, 50 pixels per second. I know that my screen is 1024, so if I want this thing to move across the screen in exactly 1 second, what should my velocity be? If I want this thing to cross from the left side of the screen 1024 pixels to the right side of the screen within 1 second, what should my velocity here be? Anyone know? 1024, right? This represents my velocity. However, if I just do this without incorporating time, how fast is it actually moving here? It actually disappeared right now. It's actually moving not 1024 pixels per second. It's moving 1024 pixels per frame. And how many frames do I have in a second? You guys know I had like 300 or 400 frames in a second. So if I take that, it's actually moving 1024 pixels per second per frame, and I have, let's say, 100, 200 frames. It's moving 204,000 pixels per second. So what I want to do is I want to take this, and I actually want to say, hey, I only want you to move a fraction of this. Basically, I want you to move a fraction of this relative to how much time has passed. So I have this concept of delta time. And this value here is going to be really tiny, right? It's basically going to represent how much time in seconds has passed since the last frame. This is the last time I called this loop. So then if I take that fraction and I multiply it by 1024, what I get is that this thing actually moves at 1024 times a fraction of a second. So what that means is that it actually, over the course of 1 second, all those little fractions have added up to accumulate to 1024. So I just made it cross the screen in 1 second flat. You could like set a clock by that. I could also make it move across the screen in 2 seconds, just by having the velocity. And it's a very discrete way of specifying velocity. That's what you guys are going to be doing today. Okay. So there's lab number 1. The second part of this lab is, so the first part of the lab is showing you guys how to get this thing to move. I want you guys to have this thing move with all the time. The next part of that lab is I want you to have it reverse the direction when you press a key. So once you have the concept of this thing having velocity, I'm moving 512 pixels per second. What if I wanted to make it move to the left, right? How do I change that? How do I change this velocity to make it move to the left? Make it negative, right? So I have this concept, if I flip the direction of this velocity, it'll move to the left. So what if I connected that to a key? Think back to how I had you guys hide the rectangle. What if you had a variable that kept track of whether you're moving to the right or to the left, right? So if you have a variable, when you press a key, you can just change that variable. And then you can use that variable in this move function here. Okay? That's how you're going to handle collision to start. The first, you're going to start with pressing a key. Then you're going to use an if statement to see if that ball's position is off the edge of the screen. And if it is, you're going to make it reverse direction again. Okay? So I want you guys to do lab number 1, which is those 3 things. Follow the instructions. I basically broke down how to set up delta time. I want you guys to make it so that there's a little bit of an extra exercise. I want you to make the space bar have the thing that actually starts moving the ball. Okay. Again, think back to how I had you guys set the space bar to hide and unhide. You're going to need the variables to track whether the ball should be moving or not. Okay. All right.